Okay, hi everyone. Something that is super important for TPN specifically is glucose oxidation rate. Let's just write TPN. So there's little bits and bobs that you need to know about or you need to consider when you calculating TPN. And one of them is the glucose oxidation rate. Okay. So what is glucose oxidation rate? So it's in the name, right? It is the rate at which the liver breaks down glucose. So rate at which the liver breaks glucose. Okay, that's the meaning of oxidation. You have fatty acid oxidation, things like that. But in this case, we're focusing on the glucose. Okay. If we have too much of glucose, the liver won't be able to process all of it as effectively and efficiently, and excess glucose then gets stored as fat. Stored as fat, which is something we don't want. Okay, we don't want this. TPN is, well, one of the risks of TPN is that it is associated with fatty liver disease, especially over a long-term period, because you are feeding the patient through or via IV through the bloodstream, and if you give too much of something, it causes major issues. If you give too much of glucose, it will cause major issues such as fatty liver disease. Okay, we don't want that. So we have to calculate the glucose oxidation rate and try not to exceed the amounts given. Okay, so initially when we start feeding, we want to keep the rate at 2.5 milligrams per kilogram per minute or less than that. That's also fine. Okay, we don't want to exceed this. So let's just put in the appropriate sign. And then for when we increase feeds, the maximum rate is between 4 to 5 milligrams per kilogram per minute. Please make sure you're using updated guidelines when looking at the maximum rates, etc. Okay, now let's look at the formula and what do we need. So we need the carbohydrates in grams. Okay, we need the carbohydrates in grams. We need the person's weight in kilograms. So that's why it's important to correctly estimate the person's weight. If you have taken the weight before, then that's great. Okay, so let's go ahead and do the formula. We're going to put in the carbs, okay, because we want to convert the amount of carbs from grams to milligrams. So grams to milligrams, we then multiply by 1,000. And we need to divide because it's per kilogram per minute. So I like to then, let's try and add in the minute calculation. So there's 24 hours in a day, but we have 60 minutes in an hour. So we want to know the amount of minutes in one day, which is 1440. So that's what we're using. Just gonna put this in curly brackets because it is an explanation. Okay, it's not a multiplication or anything, it's an explanation. So that's 1440. So that is your formula. Carbs in grams multiplied by 1,000 to get to your milligrams, and 1440 minutes, which is then obviously your minutes. There we go. Let's just change this to that. It's a bit easier. So that's your first part of the calculation. Once you have this answer in milligrams per minute, you then divide everything by the person's weight. So now you have this is equal to your carbs in milligrams per minute. You then go ahead and divide by the weight in kilograms, which then gives you the amount of carbs in milligrams per kilogram per minute. Okay, so let's quickly do an example. Say the weight of a patient is 70 kilograms. The amount of carbs we have is 200 grams. Just put in the units. Please always add in your units, it's easier. So let's go ahead and we'll calculate our glucose oxidation rate. So we have carbs in grams. Let's just write out the formula multiplied by 1,000 because we want it in milligrams over 1440, which is equal to carbs in milligrams per minute. We then divide this by the weight in kilograms. Let's substitute everything in. We have 200 grams of carbs over 1440. You go ahead and calculate that. What does that give you? So that gives you 138.89. You can give 2 decimal places, round up to 2 decimal places, or on your calculator, just use this answer and divide directly by weight. But if I round, let's just do that, divided by the weight in kilograms. I get 1.98. Okay, so the answer here will be 1.98 milligrams per kilogram per minute. If I don't round, so if I just say 200, because on your calculator you can do this on your scientific calculator, and you put all of this all over 70. Let's just add in the units so we're not confused. So if I go ahead and do that on my scientific calculator, it's gonna give me, so avoid, try and avoid making mistakes, okay? Because you can make a mistake very easily. So if you're gonna do it in 2 steps, you can do it in 2 steps. So I get the same answer, even if I go straight to calculating that. So there we go. So we see that this is less than 2.5 milligrams per kilogram per minute, and we can use that. Okay, so it's an acceptable feed to initially start feeding our patient. And that's how you calculate glucose oxidation rate. So that's one of the aspects of TPN.